There's one last batch of identities we want to look at, and I'm going to begin with this identity I've already discussed, cosine A plus B, which we know is this. And what I'm going to do here is I'm going to make angle A equal to angle B. So I'm just going to change these. And then if I simplify this, the cosine of A plus A is cosine of 2A, double A, which is where the name double angle identity comes from. And what I get on the right is cos A times cos A is cosine squared A minus sine squared A. So there's an identity for cosine 2A. What this means is cosine of 40 degrees is the same thing as the cosine squared of 20 degrees minus the sine squared of 20 degrees. You can verify that on your calculator to show it to be true. The point is this angle is double this angle. Now what I'm going to do is I'm going to create two more identities for cosine 2A. We already have this one, and I'm going to get other ones by taking this identity, this core Pythagorean identity, cos squared plus sine squared equaling 1. And I know that because of this, that cosine squared theta is 1 minus sine squared theta, or sine squared theta equals 1 minus cosine squared theta. These things are all true. So what I'm going to do is I'm going to create two identities from this identity for cosine 2A. So the first thing I'm going to do is for cosine squared A, I'm going to replace that with 1 minus sine squared. So that would be 1 minus sine squared A minus this sine squared A, which means that cosine 2A is 1 minus 2 sine squared A. Okay, there's a second identity for cosine 2A. And then I'm going to create a third one by taking this result and this time replacing sine squared with 1 minus cosine squared. So I'm going to get cosine squared A minus bracket this, and if I distribute the brackets I get cosine 2A is 2 cosine squared A minus 1. So three different identities for cosine double the angle. So we can do the same thing with sine, except we're not going to get three different identities. We're just going to get one this time. I'm going to make A equal to B. So let's just change all of these in the addition angle identity. That means that sine 2A is sine A times cos A plus cos A times sine A. Well, these are like terms, just the order of the factors is different. So that's the same thing as two of them, 2 sine A cos A. In other words, if I have the sine of 70 degrees, that's equivalent to twice the sine of 35 degrees times the cosine of 35 degrees. If angle A is this, and we match the pattern, that's equivalent to twice the angle in this position. And again, we can do the same thing with tan. Let A equal B. And that's going to make my identity tangent of double the angle is tan A plus tan A, twice tan A on the numerator, divided by 1 minus tan squared A. And there we have our new identities summarized. So just a few examples to work with these. Express each expression as a single trig expression. So the first thing is when you look at an expression, you have to kind of have an inkling as to what formula it might match. And this one, I'm thinking of cosine 2x, which is cosine squared x minus sine squared. Now the difference is that we've got sine squared minus cos squared. We've got it in reverse order, and we've also got the 2. But I can fix that by factoring out negative 2. And then if I write that as cosine squared x minus sine squared x, this statement is equivalent to this still. And then I can make my replacement. This is equivalent to this. Now let me just remind you, you can always use your calculator to get an idea as to whether you're right or not. So you could enter your original expression graphically, if we wanted to verify graphically. 2 sine angle square the ratio minus 2 cos angle square the ratio is that the same graph as negative 2 cos double the angle. That's graph 7, which is trig. And we do. Next identity, we have a constant times sine times cos. And again, with some experience, hopefully you'll click into, well, this is somewhat looking like the double angle for sine. Sine 2x is 2 sine x cosine x. So what we want to do is match the pattern with the actual values that we have here. So I'll notice that in this position I have an angle of 8x, whereas I have an angle of x right here. Well, I can change that because I know that the connection between this angle and this angle is double. So if I were to write my expression over here as sine 8x cosine 8x, what that's going to change is the double angle. It's going to be double 8x, so this is going to be 16x. Okay. As for the coefficient in front, it's supposed to be a 6, and right now it's a 2. Well, if I multiply both sides by 3, then this is going to become 6. And this is 3 sine 16x, which is what we're saying this is equivalent to. Checking with your calculator, entering the original and final expressions, graphs are in fact equivalent.